So I've been asked to talk about the LLM MCP that I've written for HRDB, or the Hatari UI debugger. It's available on Codeberg. Basically, the only thing I've done is to tie it into the existing HRDB dispatcher that already knows how to communicate with the Hatari debugger and get all the values. It's a few extra files. You can select to start HRDB with this MCP server. There's documentation on how to run it, how to add it to your LLM harness, what methods are exposed, a few special ones that I've added to get good execution to breakpoints, and screenshots from Hatari, as well as the memory buffer in HRDB for those of you who are using it. I've also started on two skills. One to help an LLM on how you actually do debugging of an old 40-year-old Atari SD platform, what's important. And I've also started one on how to write optimized code. The LLMs are pretty good at writing 68K actually, but you know, for demo purposes, it's quite important to tell them to not shift one step left, for example, when multiplying with 2. To do this, I've had the LLM parse the excellent yacht text file into a more computer-readable format, JSON. Let's hope it's good. All right, so over to what it would look like. You have my open code with an LLM at the left. You have Hatari top right and HRDB at the bottom right. And as you can see, I'm in the middle of debugging an issue here with the Atari dash. I can glide right through a single platform block, which is obviously not the right thing to do. So I'm in discussion with the LLM here. It has parsed the code base as before, and I'm telling it that the collision is not happening. Now, thanks to the MCP, as you can see in the MCP header, it's connected to HRDB. And so I'm asking it to help me out here with stepping through the code and finding out why the collision isn't being detected. These are actually tasks that LLMs are very, very good at. Stepping through all this is, it's fair to say, it can be quite boring. So why not outsource that to an LLM instead? And so that's what I'm doing here. Now I'm speeding this up for this cloud model that I'm using here is quite slow. Usually I don't use cloud models, but I'm unable to use my GPU to record this video at the same time as I would use the GPU to run a local LLM. So you'll have to accept the fact that it's a cloud model. Anyway, it knows 68K pretty well. It understands that it can read out the registers and get the symbols from the PRG file and study whatever it is in the memory ranges when it has hit a breakpoint. And as you can see, HRDB itself is also being updated here. So when the LLM uses these methods, what's being showed in HRDB is also changed, so you can follow along with the breakpoints that are set and the registers, etc. The LLM is able to get both screenshots of Hatari as well as from the HRDB memory buffer. Depending on what you're doing, it might be that the memory buffer is in some other graphics format. Now here's the LLM just stepping through the drawing, getting the player closer to this column, trying to figure out why the collision detection isn't working. I can break the LLM whenever I want to and give it more information, like I did here. And all of a sudden the player is inside the column, and the video will end here because the LLM is still working on figuring out why the collision detection isn't working. I hope this MCP server in HRDB is going to be of interest to someone. I've actually already fixed 2 bugs in Atari Dash that were pretty boring to trace myself with the help of an LLM. The code it produces is okay to have as a reference, and then you'll have to jump in and optimize it yourselves. Anyway, that's all. Enjoy.